Hey, sixth graders. I'm checking in today with Chapter 6, Lesson 3, Algebra, Variables and Expressions. Don't let that word algebra scare you, though you've actually been doing algebra since kindergarten. We just maybe didn't tell you that it was so. So, what are we learning today? We're learning how to solve expressions that have variables in them. And we'll talk about what those variables are in just a moment. Another thing, what is this useful for? Well, we can use it to solve formulas, use formulas to solve problems such as how fast am I going if I know the distance I'm going and the speed I'm going at, okay? Or what's the volume of some odd 3D object? We can also use it to calculate how much we're going to owe in taxes on something we buy at the store or how much taxes will come off our paycheck. All right? So basically, there isn't a day that goes by when there isn't some math problem you may be solving that has a variable in it. And here's how that works. Okay, so in algebra is like a language and it has symbols, including variables, which are just letters that represent a number. Now we could use a picture too. For instance, you've seen, let me switch to a pen here. If you have a snowman plus a snowman plus a snowman, and that all equals 18, what is each snowman worth? 6, right? Because 6 times 3 is 18, or 6 plus 6 plus 6 is 18. We could refer to a snowman then as a variable because it's a symbol that represents a number. Okay? So these things right here need to be written in. Okay, I pre-wrote them to save time, but I'm going to read them to you now. So math meaning of a variable, a symbol used in place of a number. Examples, you might see an X or a Y or an N or a snowman. All right, variable has an everyday meaning though, and that is just that something is able to change or vary. For example, you might hear a news broadcaster speak of variable wind, meaning wind doesn't blow at the exact same speed all day long. Okay? So here it says non-examples of variables. Numbers are not variables because they give an exact amount. Okay? Let's take a look at this real world link. A box contains an unknown number of markers. There are 2 markers outside the box. The total number of markers is represented by the bar diagram below. So we've broken up part of it into an unknown amount of markers that are in the box, and then we know there are 2 markers outside the box. So suppose there are 14 markers in the box. Oh, so if we know how many markers are in the box, then we can find the total number of markers. So, wait, I need to switch to a pen here. If we know there are 14 in the box, then that's just a matter of adding 14 plus the 2 outside the box. So that would be 16 markers in all. Okay? So here on our bar diagram, initially this was a variable. It was an unknown. There could have been 3 markers in the box. We didn't know that yet, though. Let's take a look at this. All right, so algebraic expressions. You've heard me use that term before. They contain at least one variable and at least one operation. Operations being plus, minus, multiply, divide, right? So this is an algebraic expression. It has a variable and an operation, okay? Another thing you're going to need to know, and if you think you might forget, please write this in your notes. So think about this. If we are going to use x as a variable, and we often do in algebra, and then we put a times 2, is that going to get confusing? it absolutely is going to get confusing. So we have other ways to write the times symbol. We might use a dot in the middle of the error. So it wouldn't look like this, 5.2 or x. It would be up in the air a little bit. So it would be 5 times 2. It would look like that, like the decimal is up high a little bit. Okay, we might also use parentheses. We could do 5 times 2, or we might just put the variable right next to the x, 2x. That would mean 2 times whatever x stands for. Okay, so let's take a look at some expressions that have that in them. Let's see here. So this says evaluate, that means solve it. 16 plus b if b equals 25. So where the b is, that's the variable. We are going to replace it with the number 25, which gives us 16 plus 25, which is 41. Let's look at another one. Evaluate, that means solve. X minus y if the x equals 64 and the y equals 27. So we will plug 64 where x is in, and we'll put 27 where the y is. That gives us 64, take away 27, which is 37. Okay? Evaluate 6x. That means 6 times x, right? But we didn't want to do xx, because then we wouldn't know, is that a variable? Is that a multiplication symbol? Okay. Ooh, we're putting a fraction in where's the x is. So I'm going to do this one off to the side here. 6 times 1/2. What do we do first? We put the whole number over 1. And here they just solved it for you. But let me give you a quick reminder. I'm going to erase this and make it even. Okay. All right, 6 times 1/2. All right, we can cross cancel here, okay, because 6 and 2 are both divisible by 2. So 2 divided by 2 is 1. 6 divided by 2 is 3. Then when we multiply straight across, 3 times 1 equals 3. 1 times 1 equals 1. And 3 divided by 1 is 3, which is what they got. Okay? Just a reminder that you can do that. Cross-canceling makes it much easier at the end when you don't have to simplify your product or sum or whatever. Okay? Or not, well, not sum. You wouldn't cross-cancel if you're adding, right? Okay, so here we go. A is going to equal 6. B is going to equal 4. And C is going to equal 1/3. So here we have, in A, we have A, so that's 6. 6 plus 8. Oh, okay. 14. I'm going to put a box around my sum. Write it over here on the side. All right, let me switch colors here. A again, that's 6. Minus, oh, we have a B. 4. Okay, 6 take away 4 is 2. Box my answer. Put it off to the side. Change colors again. A, that's 6. There's a dot in the air. That's times. I'm going to keep the dot. B, what is B? 4. 6 times 4. Oh, okay. So far, just multiplication facts, right? 24. 24. Okay. Let's see, what color have I not used yet? I guess it's just yellow. 9C, that means times, right? When you have a variable right next to a number, it means time times something. So 9 times, what is C? Oh, 1/3. Okay, let's put our whole number over 1. Ooh, we get to cross cancel because 9 and 3 are both divisible by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. Now we multiply straight across. Okay, numerator times numerator. 3 times 1 equals 3. 1 times 1 equals 1. 3 divided by 1 is 3. Box my answer, 3. I feel pretty good about that. Hopefully you do too. But we're going to get lots more practice. So we'll just keep working on it. All right, note. To evaluate multi-step expressions, replace each variable with the correct value and follow the order of operations. Oh, maybe we should just write that right now in the notes here. PIMDOS. We were talking about that in lesson 2, right? So P is grouping, parentheses, absolute value, brackets, which we haven't seen any expressions yet, but we will. Exponents, then multiplication, left to right, and addition, subtraction, left to right. Okay? So what have we got here? 5t plus 4, t will equal 3. So they plugged that in. It became 5 times 3 plus 4. We do the times first. 15 plus 4, 19. Ooh, here's a fun one. 4 times x squared. If x equals 1/8, what would 1/8 squared look like? Well, that would be 1/8 times 1/8. Multiplication, we multiply straight across. So 1 times 1 is 1. 8 times 8 is 64. That's what they have right here, right? And remember, 4 times 1/64th, put your whole number over 1. 4 over 1 times 1 over 64. And then they don't show the step here, but they cross-canceled most likely. Okay, so 4 and 64 both divisible by 4. 4 divided by 4 is 1. Okay, and what is that? 4 goes into 64. 4 goes into 6 once. 4, subtract 2, bring down that 4. Oh, I see it now, 16. So we have 1/16. Okay, let's look at another one. Oh, they are really challenging you with the fractions today. Are we afraid of that? No, we just need to set them up neatly and take our time. So we have 10 times whatever a is plus 7. And a is going to be 1/5. So that would be 10 times 1/5. Put your whole number over 1. Ooh, I see an opportunity to cross cancel. 10 and 5 are both divisible by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. Multiply straight across. 2 times 1 is 2. 1 times 1 is 1. 2 over 1 just equals the whole number 2. Oh, look, I could have done it over here. So we have 1/5, and then, and 10 times 1/5 ended up just being 2. 2 plus 7 is 9. Okay, let's try some on our own. Not completely, I'm still here. Okay, so E. That's 2 times whatever D is minus 5. D is 12. So that will be 2 times 12 minus 5. PIMDOS says, order of operations says we do multiplication first. 2 times 12, 24 minus 5. Well, 24 minus 4 is 20 minus 1 more is 19. So 24 minus 5 is 19. Box my answer, 19. Let's switch colors here. Okay, so we have 50 minus 3 times whatever D is. So F 50 take away 3 times, and D is 12. Order of operations says multiply first. So we have 3 times 12, that's 36. 50. So we have 50 take away 36. If you were not comfortable doing that in your head, please set it up vertically over here somewhere. Okay, and remember, you cannot take 6 from 0, so you need to borrow. Okay, so 10 take away 6 is 4. 4 take away 3 is 1. So we know our answer is 14. Could we do it another way? Well, I would think in my head 50 take away 30 is 20, and then 20 take away 6 is 14. That's what I would do. Okay, so 14. One more. Let's use purple. Okay, G. 9 times E squared. What is E? So we have 9 times, E is 1/3. So I'm going to use parentheses here. 1/3 squared. Okay, so 1/3 times 1/3. We multiply straight across, so 1 times 1 is 1. 3 times 3 is 9. So that becomes 9 times 1/9. Ooh, this is a fun one. We can cross cancel because 9 and 9 are both divisible by 9. All right, 9 divided by 9 is 1. 1. When we multiply straight across, 1 times 1 is 1. 1 times 1 is 1. 1 divided by 1 is 1. There's my answer. Okay, 1. Oh, all of that just became a whole number 1. Go figure. Is there any more here? Yes. Okay, Khalil is wrapping a gift for his brother's birthday. The box has side lengths that are 1/2 foot. Use the expression 6 times s squared, where s represents the length of a side, to find the surface area of the box he is wrapping. All right, I'm going to backtrack a little bit, okay? Because they're talking about surface area. We've talked a lot about volume. We find volume by doing length times width times height. Surface area means that we need to know the area of every face added together. So let's think about area. So if we were to take the area of just this one square face right here, I'm going to redraw it right here, okay? 1/2, 1/2, okay? Area equals length times width, right? Okay, so that would be 1/2 times 1, oopsie, typo, 1/2, which would equal 1/4. So the area of just one face or one square would be 1/4 square feet. Okay? So, but what they asked for is surface area, and that means add all the area of every face together. All right? How many faces are there on a cube? Think about a Rubik's Cube. How many faces are there, or sides? Well, I can see them. I've got a bottom here and a top. That's 2. And then I have 1, 2. There's the back there, 3. And this side over here, 4. So that's 6 faces in all, which is where this 6 comes from. 6. And why did they do side squared instead of times length times width? Well, because these are square faces. So each side is the same. Remember, it's 1/2 times 1/2. So instead of doing 1/2 times 1/2, they're doing 1/2 squared. That's a 2, basically. Or 1/2 times 1/2, right? Okay, so 6 sides, 6 faces, times how you find the area of one of these squares. 1/2 times 1/2. All right? That's what they're doing there. That's what surface area is. Now I'm moving on. Evaluate, that means solve each expression. That means it's a math problem with a variable in it or a letter representing a number. Okay? So our key here is that m will equal 4, z will equal 9, and r will equal 1/6. Got it? Okay, let me make this a little bit darker here. That way our eyes can bounce back up to it quickly. Okay, so here we have 3 plus whatever m is. M is 4. So that is 3 plus 4, 7. Note to self, if you put a box around it, I really don't care if you write it up here on the line as well. Okay? It makes it really easy for your teacher's eyes to see. You don't need to write it twice. Here we have whatever z is minus m. Oh, 2 variables. That's exciting. Remember our definition of an expression has to have a variable and an operation. It didn't say it had to have a number. Cool. Z is 9 minus M is 4. 9 minus 4, that's 5. I'm going to box it. Ooh, 12R. That means 12 times whatever R is. R is 1/6. 12 times 1/6. Put my whole number over 1. Ooh, I can cross cancel here. 12 and 6 are both divisible by 6. 6 divided by 6 is, 6 divided by 6 is 1. 12 divided by 6 is 2. Multiply straight across. 2 times 1 is 2. 1 times 1 is 1. 2 divided by 1 is 2. There's my final answer. All right. 4 times whatever M is minus 2. So 4 times M is 4 minus 2. Order of operations says multiply first. 4 times 4 is 16 minus 2. That's 14. Box my answer. 60 times whatever R is minus 4. So 60 times, what is R? 1/6. Oh, minus 4. Put my whole number over 1. And I can cross cancel here. 60 and 6 are both divisible by 6. 6 divided by 6 is 1. 60 divided by 6 is 10. All right, 10 times 1 is 10. And 1 times 1 is 1. I don't really need to write that part though, do I? Because I know that 10 divided by 1 is just 10. And don't forget this minus 4 right here. Minus 4 equals 6. There's my answer. Okay, or my solution. 3 times whatever R is. So 3 times R squared. So we have 3 times R is 1/6 squared. So we're going to need to do our exponent first, right? So that is 1/6 times 1/6, which equals 1/36. So we've got 3, I'll put it over 1, I know I'm multiplying by a fraction, times 1/36. And I can cross cancel. 3 divided by 3 is 1. 36 divided by 3 is 12. Okay? 1 times 1 is 1. 1 times 12 is 12. Final answer. Boom. All right. Ooh, word problem. Okay. The amount of money that remains. Oh, so we're getting change for a $20 bill. Okay. After Melina buys 4 party favors, and we're going to use P for party favors, P for dollars, for P dollars. Okay, P for dollars. Each they set up the formula for us. How nice of them. 20, that's $20 minus the 4 party favors times the amount that they cost. Well, they're going to cost $3. Okay, so find the amount remaining. So what's her change after she pays with the $20 bill? How much change does she get? Okay, so I'm going to rewrite this. 20 minus 4 times $3. 4 party favors times $3. Order of operations says we multiply first. 4 times 3 is 12. So now we know we paid with the $20 bill. She owed 12. Okay? 20 take away 12. Well, 20 take away 10 is 10. 10 take away 2 is 8. So she's going to get $8 back from the cashier. Let's take a look at this down here before we leave each other for the day. It says, how are numerical expressions and algebraic expressions different? Well, notice I color-coded this for you here, okay? Numerical expressions have numbers and operations, meaning add, subtract, multiply, or divide, or some combination of those. Okay, and algebraic expressions have the same. They have numbers and operations. They also have variables, meaning some sort of symbol representing a number. Okay, and we can remember that numbers have numbers and operations by remembering that numerical has the first part of the word number in it. Okay, all right, go try some on your own. I highly recommend you work together so you can remind each other of order of operations and get the hang of these things. Think of them as puzzles, they're just fun challenges. All right, bye, guys.